Welcome back to the Learn with PHNX series. Today we're diving into the fascinating world of cross-chain interoperability. We'll explore how different blockchains can communicate and interact, making the user experience smoother and more cohesive. Let's get started. A core impediment to the democratization of crypto lies in its wide diversity. It is difficult to expect users to navigate across several blockchains, each with its own wallet and constraints. Achieving blockchain interoperability is essential to allow blockchains to communicate with each other, thereby easing the user experience. Multiple approaches exist, and we will explain how interoperability works. Let's start with a real-world example. Trains. Different countries run different networks, sometimes with very different technical requirements. For instance, the high-speed French train TGV could initially not run on the Spanish network due to different rail widths between the two countries. Would it be realistic to expect Spain to change its entire rail network to accommodate the French train? Of course not. The solution was to create a system that could change the distance between the wheels without stopping the train. Now, it can run in both countries, facilitating the travel of passengers and growing traffic. This is what we should aim for with blockchain, a technical solution that does not imply significant changes for the networks and is smooth if not invisible for the users. It is important to recognize the need for different blockchains. They do not solve all the same issues or have the same use, as they were not built on the same foundations. So how do we make two different networks communicate with each other? Well, it depends on how much communication is required to start with. This will define the degree of interoperability needed. Let's first look at two common cross-chain technologies, oracles and sidechains. The former feeds the blockchain with data from the outside world of that chain. The latter includes all Layer 2 solutions, and we invite you to watch our video dedicated to Layer 2 for more information. In a nutshell, a sidechain will use a specific communication protocol and utility tokens to interact with the main blockchain. But let's look at the wider range of interoperability solutions, starting with bridges. Bridges are dApps, allowing you to move a token from one blockchain to another. Using the word move may be a misuse of language, as we will see how it actually works. Three different mechanisms exist. Lock and unlock system. You lock Radix on the Radix blockchain and unlock eRadix on the Ethereum blockchain, for instance. You need two liquidity pools, one on each blockchain. Usually, this type of bridge offers incentive programs to attract liquidity. On Radix, we invite you to check InstaBridge, which provides a bridge between Radix and Ethereum. Wrapped tokens. This involves locking tokens on the source chain for wrapped versions of the token to be minted on the destination chain. If you've ever held WETH, you've interacted with such bridged assets on the Ethereum chain. You can unlock the tokens on the source chain by burning an equivalent amount in the wrapped version. Burn and mint. The original token from the source chain is burned to mint a new one on the destination chain. With that mechanism, the total number of tokens across the two chains does not change. Some swap platforms now offer the possibility to swap tokens across chains. For that, they rely on what we call atomic swap protocols and cross-chain automated market makers. The former enables peer-to-peer transactions on different chains. If Peter wants USDT on Radix and Paul wants the same but on Ethereum, they are matched and proceed to a transfer on each chain. The latter does the same but relies on liquidity pools on each chain. Less known solutions include native payments, with the use of a dApp on a first chain that will trigger a payment on a second chain in the native token of the latter. They usually relate to settlement payments. Without going into their details, as they are more complex for a simple demystifying video, we can mention contract calls and programmable token bridges. Now that we've explored the solutions for interoperability, we may want to understand how they can work. If you remember from a previous video, a blockchain works thanks to a wide network of nodes validating the state of the blockchain. So how could we get a transaction validated if it emerges from an external chain? There needs to be a relay between the two chains. Native validation. This happens where the destination chain verifies the state of the source chain to confirm a transaction and then executes the transaction on its own chain. Remember our video on nodes? Well, a light node could be helpful here to monitor the situation on the source chain, but it would be run on the destination chain. We're simplifying a bit here, but the overall idea is clear. Native validation relies on a network of relays that will transfer the information. It works better across blockchains that have a similar state machine. A typical example would be a Layer 2 interacting with its Layer 1. Web 2 validation. This occurs when a user goes through a Web 2 app to execute a cross-chain transaction. Think of centralized exchanges. You never have to worry about the chain. That's exactly what we would call Web 2 validation. Yet, this implies trust in a centralized party. External validation. This involves a set of validation nodes from a blockchain different from both the source and destination ones. The role of these nodes is to validate the state of the source chain to trigger a transaction in the destination chain. The nodes are doing off-chain computation that is then authenticated on-chain. This method may be the best as it allows cross-chain interactions between blockchains, extremely different from an infrastructure and technological perspective. It can also support much more complex transactions. Local validation. This will leverage each party checking the state of the other. A transaction is only executed if both checks are valid. This is what we refer to as atomic swap. Understanding cross-chain interoperability is key to the future of blockchain technology. As we continue to innovate and develop new solutions, the goal is to create a seamless user experience across different blockchains. Stay tuned for more exciting updates, and don't forget to like, share, and subscribe for more insights into the world of PHNX and blockchain technology. Burn to rise, reborn to soar.